Hello everyone, in this video we're going to be solving an octic trigonometric equation. So we have the sine x to the 8th power plus cosine x to the 8th power being equal to 97 over 128. And we're supposed to solve this x in the first quadrant for the sake of simplicity. Okay, let's just do that. The other solutions are just going to come quick. All right, so at this point you may just want to pause the video and try this problem yourself first. All right. Let's see what happens. Now, one of the approaches that we can use for this problem is we can write this as sine x to the 4th plus cosine x to the 4th and then square it, subtract the term in the middle, and do that again, and so on and so forth. But that'll be, just one way to do it. But I'm going to use a different approach here. What I'm going to use is actually one of the things that we used in our calculus videos in the integrals of sines and cosines, you remember? When we had even powers of sines and cosines, what did we do? For reduction of powers, we used the formulas for cosine of 2x. So cosine of 2x comes with two formulas. One of them is this one. And from here, we get cosine squared x being equal to 1 plus cosine of 2x divided by 2. And the second one gave us sine squared x being equal to 1 minus cosine of 2x over 2. And you know that it came from the fact that cosine 2x is also equal to 1 minus 2 sine squared x. Okay? That's where that comes from. Awesome. Now, what I'm going to do is I'm going to use these formulas. But first, I have to manipulate my equation. How do I do that? I'm going to be writing this equation as sine squared x to the 4th power plus cosine squared x to the 4th power. And that's actually going to do the trick. But let's see how this proceeds. Okay. Now, I'm going to replace sine squared with 1 minus cosine of 2x over 2 and to the 4th power. And this is going to give me 1 plus cosine of 2x over 2 to the 4th power. And when I do the math here, obviously from a plus b to the 4th power and a minus b to the 4th power, a lot of the terms are going to cancel out. What is not going to cancel out is going to be what? So if you consider a plus b to the 4th power, it's going to be a to the 4th plus 6 a cubed. I'm sorry, it should be the first number should be 4 plus 4 a cubed b plus 6 a squared b squared plus 4 from Pascal's triangle. You should know the coefficients. So what's going to happen is these terms are going to come with negatives and they're going to cancel out. So basically what I'm going to be getting is these terms I'll be getting them twice. So what I'm going to be getting from here is basically you should be getting a is, in this case, a is 1 and b is cosine of 2x, by the way. So you're going to be getting a to the 4th, which is 1, plus 6a squared b squared, which is going to be 6 times cosine squared 2x. And then you'll get cosine 2x to the 4th power. Okay, awesome. But you'll get this twice because they're repeated. And this expression is equal to 97 over 128. Now at this point, I can just go ahead and divide both sides by 2. And that's going to give me cosine to the 4th 2x plus 6 cosine squared 2x. And, oh, I forgot to divide by 16 here. So obviously, this expression comes with a 2, but then I have to divide by, oopsies. Why are we doing that? Okay, we're going to divide this whole thing by 16. And obviously, what that's going to give us is it's going to simplify here because what happens is I do get the top part with that 2 in it, but the bottom part is going to bring me a 16. So then this is going to be an 8. And if I go ahead and simplify this more, 8 goes into 128 16 times. Awesome. So I get a simpler expression. Let's go ahead and write that down. Cosine 2x to the 4th power plus 6 times cosine 2x to the 2nd power plus 1 is going to equal 97 over 16. Okay, we're going to simplify this even more by using the double angle formulas again. So what I can do is I can replace cosine squared 2x with 1 plus cosine of 4x over 2. And this one is going to be that expression squared, right? I'm going to replace it with this squared plus 1 is going to be 97 over 16. So let's go ahead and expand this a little bit more. This is going to give me cosine squared 4x plus 2 times cosine 4x plus 1 over 4. And these two are going to cross cancel. And that's going to give me 3 of cosine 4x plus 3 plus 1. That's going to be a plus 4 here. And that's going to be 97 over 16. Awesome. What am I going to do next? Well, I'm just going to multiply everything by 4 to clear the fraction, at least part of the fractions. So I'm going to be getting this expression from here, the numerator. Plus, if you multiply this part by 4, you will get 12 cosine 4x plus 16 is equal to 97 over 4. Awesome. We're almost there. Let's go ahead and simplify this. We'll get cosine squared of 4x plus, okay, 2 cosine of 4x is going to give me, and then plus 12 cosine of 2x. That's going to give me 14 cosine of 4x. 1 plus 16 is going to be 17. If I go ahead and subtract 17 from this number, I should be getting something nicer, don't you think? Well, 4 times 17 is going to be 68. And if you subtract 68 from 97, right? 97 minus 68 is going to be 29. Okay, cool. So I'm going to be getting this plus that is equal to 29 over 4. Beautiful. Okay, here's the million-dollar question. Is there a way to factor this expression? Yes, if you know that 29 over 4 can be factored into two expressions whose sum is 14, and that can be done. Why? Because you can basically split it up into 29 halves and 1 halves, and one of them has to be negative, and their sum is going to be, actually it's the other one, not this one, because we want their sum to be positive, so we're basically dealing with these two. You see, notice that the sum of these two numbers is equal to 14. Beautiful. So now we can write it as cosine of 4x plus 29 over 2, that's not good, and then cosine of 4x minus 1 half, and the whole thing is equal to 0. Beautiful. Okay, now hopefully at this point you notice what's going on here, because cosine of 4x cannot equal negative 29 over 2. Obviously, it's out of the range, right? So cosine needs to be less than or equal to negative 1, or between negative 1 and positive 1. So it needs to be greater or equal to negative 1, but this is way, way less than negative 1. So this solution is not accepted, but the other one looks pretty good. So let's go ahead and take a look at that. Cosine of 4x is equal to 1 half, which means, okay, what is that supposed to mean? It means that 4x can be pi over 3, right, which is equivalent to 60 degrees, obviously, or 5 pi over 3. Okay, as you know, these two angles can add up to 2 pi, and x is still in the first quadrant, because what we're going to do here is we're going to divide both sides by 4, and we're going to be getting as x1, which is our first solution, pi over 12, and x2 is going to be 5 pi over 12, and you can easily verify that they're both in the first quadrant. All right, so those are my solutions, and the other solutions can be easily obtained. I hope you enjoyed the video. Thank you for watching. Please comment, like, and subscribe, and I will see you in the next video. Until then, take care. Bye-bye.